All right, let's talk about one of the biggest challenges for any computing student. How do you take a really cool project idea and turn it into a high-scoring, successful submission? We're going to look at how to avoid the common traps that can sink even the best projects.
So, what if I told you that for a lot of student computing projects, a huge chunk of your final grade, we're talking up to 37 marks, could all hinge on understanding just one single, really powerful principle? Well, that's exactly what we're breaking down today.
And that principle is what we call the golden thread. You should think of it as the lifeline of your entire project. It's the clear, visible proof that connects every single requirement from the very beginning all the way through every single stage right to the very end.
Okay, so let's really get into this. The biggest challenge for anyone marking your project is just figuring out if you actually delivered on what you promised at the start. If they can't easily see that connection, you're at risk of losing marks, even if you did all the work. Here's a little secret, something markers actually do. When they get your project, a lot of them will literally grab a piece of paper and write down your main requirements. Then, as they go through your design, your code, your tests, everything, they physically tick them off one by one. Your job is to make that as easy and obvious for them as possible.
So let's start at the beginning, the analysis and design phase. This is where that golden thread is first created, and you'd be surprised how even a tiny little flaw in this early blueprint can make the whole thing unravel later on.
This right here is a perfect example of a super common mistake. A weak requirement like I will use a 2D array, well, that's generic. It could be from any project in the world. But a strong requirement is specific. It explains how you're going to use it and why you're going to use it to solve a problem that is unique to your project. That's the detail that scores points.
And this same idea applies directly to your project plan. If your list of tasks just has generic phrases you might have copied from the marking guide, like design solution, well, those are often worth 0 marks. They have to be specific to what you're building, like design the database schema for user profiles. That proves you've actually thought it through.
And while you're at it, watch out for these other common slip-ups. Don't create a timeline that has you working on Christmas Day. It's just not realistic. If you're building a website, don't forget to list the web browser as a resource. And this is a big one. Make sure your plan clearly shows your advanced algorithm working together with your advanced data structure. They can't just be two separate things you mention.
All right, so with our plan solid, it's time to get into the coding and testing. And at this stage, the game changes. It's all about one thing: proof. You have to remember, in the eyes of a marker, if there's no evidence, it didn't happen, period.
And honestly, this is the single biggest reason why students don't get the marks they deserve. It's not because they didn't do the work. They did the complex coding. They did the testing. It's because they failed to prove it with clear, undeniable evidence. Okay, let's take a database update. How do you prove your SQL query actually worked? Well, you can't just show a screenshot of the final result. You have to show the whole story. Show the data before you ran the code, show the code itself, and then show the data after. That before, during, and after approach is your undeniable proof. And your testing evidence really needs to cover all the bases. I'm talking normal, extreme, and exceptional data. And if you have a requirement like your program should be easy to use, you need a real plan to test that. You can't just say it. And please, always include screenshots of your error messages and final scores in action.
Now here is a super simple but incredibly powerful tip. When you print out your code, just take a highlighter and mark the sections that show your advanced algorithm and your advanced data structure. It makes the marker's job so much easier, and it guarantees that your most complex, high-scoring work gets noticed. And finally, we're at the finish line, the evaluation. Now, this section is often rushed, but it's your last best chance to show some real critical thinking and lock in those final marks. It's the ultimate test of that golden thread. A really strong evaluation will always talk about future maintenance. You should be comfortable with these 3 main types: corrective, which is just fixing bugs; perfective, which is improving existing features; and adaptive, which is updating your project for new technology.
But here is the absolute key. You get 0 points for just defining those terms. You have to apply them directly to your project. What specific bug might need a corrective fix? What perfective feature would you add next to make it better? How might it need to be adapted if a new operating system comes out? You've got to give specific examples. And maybe most importantly, just be honest. A A marker would so much rather see you acknowledge that a requirement wasn't fully met and explain why, than to read you pretending everything is perfect when the evidence says it isn't. Honesty shows maturity and a real understanding of how development works.
So as you put the finishing touches on your work, just ask yourself this one simple question. Can a complete stranger pick up your report and trace every single one of your original requirements through every stage of your project? If the answer is yes, then your golden thread is strong and you are absolutely set up for success.